welcome to Year 9 Science and Our Amazing Earth, our second unit for the year. In this video number 12, we're going to be focusing on the global distribution of earthquake zones. Now, we did look in a previous video at how the distribution of volcanoes can be linked to the theory of plate tectonics and the identification of boundaries between the plates. Now we're going to be looking at the same thing, but this time the distribution of earthquakes, to see if we can see a similar sort of correlation. And as you would probably expect, we do. Just like when we map the volcanic distribution or the distribution of volcanoes around the Earth, when we do the same thing for earthquakes, it also correlates very highly with the plate boundaries and therefore provides yet another piece of evidence for the plate tectonic theory. Earthquakes do vary in their frequency and intensity, and there's been a lot of work that's been done with seismographs, analysis, and also the development of seismometers to be able to measure earthquakes. And what we've been able to do with the data is to use that data to help us triangulate and work out the important locations of epicenters of earthquakes around the Earth. So if you think about the fact that if we look at the Earth's surface, the epicenter is going to be the place where the earthquake has originated. In actual fact, the epicenter is just the place above the focus. Okay, so the focus is under the surface of the Earth, and it could be shallow or it could be deep, but this is actually the origin. But because we can't identify that precisely, what we can do is use our seismographic data to effectively what we do is we work out the distance that we are from a particular earthquake, which if we plot that down on a two-dimensional structure like a globe, gives us a circle. A second piece of data should hopefully give us two potential places where this could occur. A third will give us the pretty much the exact location. So where all three of these circles meet, we can identify the epicenter of a particular earthquake. Now, when we start to analyze earthquakes, because we know that they've created a lot of implications for us, both in terms of the potential for destruction of buildings, of homes and other constructions, but also the loss of life and their correlation with things like tsunamis, which is just another type of disaster that has actually occurred and has been tied to earthquake activity, then we start to again see that there's a high level of correlation between the distribution of earthquakes and the mapping of the plate boundaries around the Earth. So let's have a little bit of a look at that. Once again, you can see just as a little idea about how to interpret this, you can see the most severe earthquakes that have occurred in the recent past in the red or the orange colors, and getting less and less significant in terms of their ratings on the Richter scale, which is how we measure earthquake activity, as we go into the green and the blue parts of this diagram. But again, what you can notice is some of those structures, some of those regions of the Earth that we've already looked at correlate very well once again with the distribution of earthquakes. Now again, it depends where you sort of shift these, but you can see from our perspective, we're sitting on the Australian plate. Again, we're pretty quiet in terms of tectonic activity. That doesn't mean there are no earthquakes, but there is a small number of them, and they're also not terribly severe. But you can also see this region that we talked about as the Ring of Fire before, which is kind of a little bit cut off on this particular map because it's just because of the way that it's structured. And you can see that earthquakes are highly correlated with that ring of fire that we looked at earlier on. You can also see running right through the mid-ocean ridge between South America and also Africa and all the way up is again a region of clearly defined earthquakes. A lot of that is transform faults, which are also often a feature of mid-ocean ridges. But again, that's almost nicely tied to where we've identified that mid-ocean ridge between the two South American and African plates. So these are again important observations, because this observation, namely the distribution and intensity of earthquakes, provides evidence for in support of our plate tectonics theory. And once again, always remember, our theory is our explanation. Can we explain why we see this distribution? Well, we can when we talk about plate boundaries. And because we've previously talked about destructive, constructive, and conservative plate boundaries, boundaries where two plates are moving apart from one another, or they're coming together, or they're rubbing side to side past one another. Each of these explanations that we use plate tectonics to help us to develop is correlating very highly with this distribution of earthquake zones. So hopefully what you're doing is building up a picture of how the Earth looks, how the Earth behaves in terms of its tectonic activity, and what a great model of explanation the plate tectonics theory is. Now, of course, observation and looking at these sorts of things is one important area, but we also know that there is some technologies that have developed that have also helped us to identify some of these phenomena and provide even more evidence in support of plate tectonic theory. And we're going to have a look at just a couple of those in the next video. Thanks for watching.